Okay, so reminder, the homework for 3.8 is due today, and then 3.9 is due this coming Friday. So today I want to do one example. I mean, the first question is because I've got a few students asking me how to do that. So, and then I'll try to finish up section 3.9, and then hopefully I can start doing section 4.1 today. Any questions before we start? By the way, I'm still waiting for more people to come. I'll take attendance in a bit. Any questions? All right. Yeah. And I need to take attendance. If I call out your name, that means I am, if you want to hear your name being called, like Sophia, and Daniel Witherspoon, Kristen, Adam Bailey, Joanna, Josie, friend. So, I also have Haley. I also have Will, Ryan. Are you Ryan Claire or Ryan Noble? Okay. Brighton. Matt. Jordan. Zach. This is taking way too long. Okay, anyone else that I didn't take your attendance? Oh, I also have Daniel. Okay. And Ryan Noble. Who else? 6, 8, 10, 12, 14, 16, 18. I think that's it. Derek. All right. Let's switch over to this question on the webwork. So this is webwork 3.8, question 1. So you have this graph You have this fancy graph, and then the question says that you want to start with x0 equals -1 on the graph, and then use that to find x1. So I didn't explain um, how the formula for the Newton's method was derived, but here's how it comes from. So the way you do it is you first draw the tangent line. I mean, so you first start with you start with the first point, and in this case, it's -1. So you start with that point, and then you draw the tangent line at that point. So in this case, I have -1, and the green line is just the tangent line, right? So you can move along the line, and to find a tangent line, you just need to make sure that the x coordinate is -1. Ugh. Okay, this one. So the blue point is the one you start with. The green point will be the next one. So the x coordinate for the next one, for the next point would be -3.979. So that will be your answer for x1. Does it make sense? Yeah, so that's your first one. Uh-oh. Are you allowed to enter as decimal? Yes, I think so. Yeah, this one's correct. Is there a way to type in? Good question. I think you can type in here. Right? Yeah. So, so my keyboard is not showing up, but I think you can type in here. So just click A here, and then so to find the next point, you need to replace A by -3.979, and that gives you the green tangent line, and then you find the next point on the x-axis. Is it okay? I also have Mike here. All right, so moving on. Okay, so what did we do last time? So last time we talked about antiderivative. So let me remind you. So the antiderivative of a given function is so that when you take the derivative, you get the function. So for example, when you have x to the n, what is the antiderivative? What is the antiderivative of x to the n? Anyone? So what is a function so that when you take the derivative, you get x to the n? So it's 1 over n, 1 over n plus 1, x to the n plus 1. And don't forget plus c. I think I saw 2 people studying their homework yesterday, and one of them, I don't remember which one of them forgot to put plus c. So you have to put plus c. You cannot put in any number. You have to put plus c. Make sense? Okay, and then we also talk about the derivative of some trig functions. For example, what is the antiderivative of sine of x? Cosine of x? It should be negative cosine of x. What about the antiderivative of cosine of x? Okay, positive sine of x plus c. What is the antiderivative of secant square of x? So what is a function so that when you take the derivative, you get secant square of x? Tangent of x? Antiderivative of secant tangent? Secant of x? Cosecant square of x? It's negative cotangent. And then the last one is just negative cosecant of x. And I also mentioned that the way to verify you have the correct antiderivative or not is you just take, oh no, that's not what I mean. So the way to verify if you have the correct antiderivative is you just take the derivative. So for example, the derivative of sine of x should be cosine of x. The derivative of tangent of x should be secant square of x. So on and so forth. And then the other way around is just the antiderivative. Any questions? All right, moving on. Okay, so this is what is called initial value problem. Okay, so suppose that you have three functions. Sorry, I mean suppose you have one function that's called the acceleration function, and it's given by a of t equals t plus 1. So it's a function in terms of the time, and it's t plus 1. And let's say you're given the information that the distance when t equals 1 is 10, and the velocity when t equals 1 is 3. So s of 1, this is the distance function. S of t is the distance function. V of t is the velocity. The question is find s of t and v of t. So find the distance and find the velocity. So what do we know about the relationship between a of t, v of t, and s of t? So what is the relationship between a of t, v of t, and s of t? Okay, so the derivative of the distance function is the velocity. What about the acceleration? Acceleration is the second derivative. So we can write it like this. The derivative of the velocity x is the acceleration, which is also the second derivative of the distance function. Now I give you what is the acceleration, which is t plus 1. the first step you can do, going backward, we can find what is my velocity, right? Let me say this again. So to go from the distance function to the velocity, you take the derivative. To go from the velocity to acceleration, you take the derivative again. Going backward, if I want to go from acceleration to velocity, I take the antiderivative. If I want to go from velocity back to the distance function, I take, again, the antiderivative. So velocity is the antiderivative of t plus 1. What is the antiderivative of t plus 1? Okay. So the antiderivative of t should be 1/2 times t squared. The antiderivative of 1 should be t, right? That's because when you take the derivative of t, you get 1. And don't forget plus c. Let's call it c1 here. Now, how do I find c1? Part of the question says that when the time is 1, the velocity should be 3. So when I plug t equals 1 into my equation right here, the velocity should be 3. So 3 equals 1/2 times 1 squared plus 1 plus c1. And so c1 equals 3 minus 1/2 minus 1, which is 3/2. Is it okay? Questions? Can you guys see me? I feel like that's okay. Yeah, what I did was just taking the antiderivatives. Yes. And so your v of t should be 1/2 times t squared plus t plus 3/2. That's your velocity function. Now, if I want to find the distance, I have to take the antiderivative again. So let me rewrite the velocity function on the new page. So s of t is the antiderivative of the velocity function. Huh. You can see me, but I cannot see myself. Anyway, so 1/2 times t squared plus t plus 3/2, and what is the antiderivative of all those? So what is the antiderivative of 1/2 times t squared? Okay, it's 1/2 plus 1. No, what am I doing? Okay, so the 1/2, you can forget about that because it's a constant. What is the antiderivative of t squared? It would be just 1/2 plus 1 times t to the 2 plus 1. Plus the second term, the antiderivative of t should be 1/2 times t squared. The antiderivative of 3/2 is just 3/2 times t. And don't forget the constant. And let's call it C2. Questions? Let's simplify a bit. So S of t is just 2 plus 1 is 3. So this is 1 over 6 t cubed plus 1/2 t squared plus 3/2 t plus C2. And then the question says that when t equals 1, the distance function is 10. So you plug t equals 1 into the function, should get this. I'll let you do the algebra, but C2 should be 47 divided by 6. And so S of t is 1 over 6 t cubed plus 1/2 t squared plus 3/2 t plus 47 divided by 6. So this is your distance function, and this is your velocity function. Any questions? Any questions? Okay. So I wanted to look at this example. Oh no, not this one. So this is actually a very simple example, but I think the wording is a bit weird. So it's saying that the velocity is 36 feet per second and the acceleration is 18 feet per second per second. Well, it's actually negative 18, right? Because it's decelerating. So it doesn't say which one is the constant, but you should keep in mind that the acceleration is the constant here. I think it's implicit in the question, but it doesn't say that. So you start with in this question, you start with the acceleration, which is negative 18. And then you find the velocity, and then you find the distance. Is it okay? I'm not sure about you guys. So that's the first thing that was really confusing for me. I wasn't sure which one is the constant. But anyway, so acceleration is the constant and it's negative 18. Velocity is not the constant. It's a function in terms of the time. Make sense? Questions? Any questions before I move on? Okay. No, I just say that acceleration is a constant. It's negative 18. That's it. Okay. I'll let you think about this question, and if you have any problems solving this question, let me know. I want to start a new section today, section 4.1. This is called area and distance. So I want to draw a graph, and I want to tell you what we want to do in this section. So let's say you have a function that looks like this. Let's say it's a good function from A to B. in this section, we want to be able to compute. We want to compute the area, cannot spell, the area under the graph of f of x from x equals a to x equals b. So what I mean is I want to compute the area of this region. But it's a very curvy shape, right? Which means we really don't have a formula for that. So we actually don't want to find the exact area. We actually want to approximate the area using rectangles. Here's how it goes. So we have a fixed interval from A to B. The first step is you want to split the interval into smaller subintervals. So depending on the question can say that split the interval into 10 parts. It could be 5, it could be 3. You have to look at the question. So the first step, split that into several subintervals. And then second step, compute the area of each rectangle I guess I should say the rectangle for each subinterval. Last step, you just add them up. So for each of the subinterval, you will see very soon that you would have a rectangle. So for each of the rectangle, you compute the area, and the final step is you add all the areas up, and that will be the approximation for the area under the curve, under the graph. Let's look at one example. So I want to use rectangles. Okay, I should say I want to use how many rectangles? I want to use 3 rectangles to estimate the area under the graph y equals x squared from x equals 0 to x equals 1. Okay. So y equals x squared looks like this. And I'm focusing on the interval from 0 to 1. And I want to split the interval from 0 to 1 into three parts because I'm using 3 rectangles. Okay. Maybe I should draw this on the next page. Okay, I should do that. Actually, never mind. So okay, there are 2 parts of the question. The first part is I want to compute the left-hand sum. So I want to compute the left-hand sum using 3 rectangles. Then I'm going to redraw the graph again. Okay, so because I'm using 3 rectangles, so I have 3 rectangles. First step, I want to compute the width of each rectangle. So my notation delta x, it's the width of each rectangle. The interval is from 0 to 1, and I have 3 rectangles. So what is the width of each rectangle? So how do I split 0 to 1 into 3 equal parts? It's 1/3. So the way you compute that is you do 1 minus 0. Those are the endpoints, right? Divided by the number of rectangles. So in this case, you have 3 rectangles, so you divide by 3, which gives you 1/3. I want to emphasize this because, so, okay, I'm just going to write down the formula. So the top is always the length of the interval. And then the bottom 3, it comes from the number of rectangles. So the compute the width of each rectangle, what you do is you compute the length of the interval, you divide that by the number of rectangles. In this case, is 1/3. Any questions so far? And in this case, I want to compute the left-hand sum. So I need something that's called the left endpoints. All right, so the width of each sub interval is 1/3, right? You start from the point 0, the next point should be 1/3, the next point should be 2/3, and then the last point should be 1. By left endpoints, I mean you're taking the points, you're taking all the points starting from the left-hand side, which is 0, 1/3, and 2/3. And then you are removing the last one. You don't include the last one. Make sense? So 11 points means you start from the very left, and then you don't include the last one. Is it okay? Now you should keep in mind that the number of left endpoints should be the same as the number of rectangles. And in this case, I'm taking 3 rectangles, so I should have 3 endpoints. So that's correct. 0, 1/3, and 2/3. Those are the correct number of, that's the correct number of rectangles. I mean endpoints. Is it okay? Okay. Now using this 3 endpoints, I'm going to draw some rectangles. So between 0 and 1/3, I'm looking at the left endpoint, which is 0. Use the 0 point to draw the rectangle, and on the graph, it would be just like this. So I'm using 0 as a left-hand point. On the graph, 0 is right here, right? So the rectangle should look like this. It's just a line. For the second interval, 1/3 to 2/3, I'm using 1/3 as my left-hand point, which is right here. So the rectangle should look like this. Same thing from the last interval. So from 2/3 to 1, I'm using 2/3 as my left endpoint. So the rectangle for the last region will look like this. Is it okay? Any questions? Okay. So no. So the left hand sum would be the sum to answer your question. Didn't I just say that I want to compute the area of rectangle? I mean, yes, theoretically you can use trapezoids, but in this section we only want rectangles. Is it okay, Derek? So the left hand sum will be just the sum of the areas of the rectangle. So can someone tell me what is the area of the first rectangle? First rectangle here. 0. It doesn't have any height, so it should be 0. The second rectangle, so for the second rectangle, if I want to compute the area, I have to know the width and the height. What is the width? The width is always 1/3, right? We already computed here. So delta x is the width. It's always 1/3 times the height. What is the height in this case? It's 1/6, 1/9. How did you get that? So this is the height. This is the height, right? This is the height of the rectangle. And this is also the y value for 1/3. So to compute the y value, you simply need to put 1/3 into the function. So if you put the left endpoint, which is 1/3 into the function, you're going to get the height. And in this case, it's 1/3 square. Same thing for the last one. So to compute the area of the last rectangle, you need to multiply the width by the height. Again, the width is always 1/3. The height, you use 2/3 to compute the height. And in this case, it's 2/3 square. Questions? Any questions? Yeah, I will let you do the algebra. Second part, I want to compute the right hand sum. So the idea is almost the same, but in this case, but instead of taking left endpoints, I'm taking the right endpoints. So delta x should still be the same. It's 1/0 divided by 3, which is 1/3. So the width of the rectangle, the width of each rectangle should be 1/3. but the right endpoints are not the same anymore. So you have 0, 1/3, and 2/3. Right endpoints means I'm omitting the first point, and then you take the rest. So 1/3, 2/3, and 1. So excluding the first point, and then including everything else. Make sense? Once again, the number of endpoints should be the same as your number of rectangles. No matter what, the number of endpoints should always be the same as the number of rectangles. Okay, now what do we do next? We draw some rectangles. Use red. Okay, I'm doing the right-hand sum. So for the interval from 0 to 1/3, I'm using the right endpoint, which is 1/3. And using that, I need to draw a rectangle like this. Is it okay? For the second interval, you do the same thing. So between 1/3 and 2/3, you pick the right endpoint, which is 2/3, and draw a rectangle like this. And between 2/3 and 1, y above the curve. So first of all, I'm not picking rectangles above the curve. I'm picking the right endpoints. So for the first interval from 0 to 1/3, I'm picking 1/3 as the endpoint, which means the rectangle should look like this. So the endpoint you pick has to touch the curve, right? If I'm picking 1/3 as the endpoint, the point it touches the curve is right here. And so the rectangle looks like what I just drew. Make sense, Matt? Okay. But that's a good question. So that's something I will talk about later. For now, we are only looking at left-hand sum and right-hand sum. So left endpoints and right endpoints. All right. So the second interval, you're picking the second. You're picking the right endpoint, which is 2/3. So using that, you can draw a rectangle like this. Similar for the last one. So for the last interval from 2/3 to 1, you're picking 1 as your right endpoint, and so your rectangle looks like this. Any questions? And so now I just need to compute the area of each rectangle, and then I need to add them up. So for the first rectangle, what is the area here? I'm asking the area. Okay, so you multiply the width by the height. And again, the width is always 1/3 in this case. The height, you get that by plugging 1/3 into the derivative. Sorry, not the derivative, the function. So you plug 1/3 into the function. That gives you 1/3 times 1/3 square. For the second one, width is again 1/3. The height is 2/3 square. The last rectangle, the width is 1/3. The height, you plug 1 into the function, you get 1 square. Questions? Any questions? Okay. Um, I guess you can see by now that I don't even have to draw the graph, right? So how do I get all these numbers? How do I get 1/3 square, 2/3 square, and 1 square? I get them by plugging in my endpoints into the function. Right? So once you find what are the right endpoints, you can right away plug them into your functions, into your function to get the height. So these are the height. And because the width is always the same, so in this case it's always 1, you just multiply by those heights by 1/3. Am I making sense? So in general, if you get a question that's asks you to find the left-hand sum and right-hand sum, you don't need to draw the graph. You can if you want, but you don't need to draw the graph. Any questions? Okay. The next thing I want to talk about is overestimate and underestimate. Yeah. So overestimate means that your approximation should be bigger than your exact approximation should be bigger than the exact area. And that means you're taking, so all the rectangles you're taking should be above the graph. Is it okay? For underestimate, the approximation would be smaller than the exact area. And that means all the rectangles you're taking should be below the graph. Is it okay? Now, going back to our question. So we use two methods to compute, to approximate the area. The first one is the left-hand sum. The second one is the right-hand sum. Which one is the overestimate? Which one is the underestimate? Good question. So is right-hand sum always the overestimate and is the left-hand sum always the underestimate? Okay, one at a time. So in this case, the left-hand sum is it overestimate or is it underestimate? It, I'm asking the left-hand sum. Is it over? Yeah, it's underestimate. What about the right-hand sum? It's over. So in the above example, I guess I should call this remark. In above example, left-hand sum is the underestimate. Right-hand sum is overestimate. But is it always true? Is this always correct? Nope. So it really depends on your function. This is not always correct. It depends on how your function looks like. So your function could look like an increasing function like this. For an increasing function, left-hand sum would be the same as the underestimate. Right-hand sum would be the same as overestimate. For a decreasing function, everything is flipped. Left-hand sum would be the same as overestimate. Right-hand sum would be the same as underestimate. If it's neither increasing nor decreasing, then it's neither. You have to actually draw out the graph to look um, for the endpoints. Make sense? All right, so I only did the left-hand sum and right-hand sum, and I briefly talk about overestimate and underestimate today. I'll do maybe one more example next time about overestimate and underestimate. Any questions before I let you leave? I think there's also one person that I didn't take the attendance. So someone joined the meeting late today. Who is it? I have Ryan, I have I think it's Daniel. No, the other Daniel. The other Daniel. Anyway, I got it now. So yeah, that's it for today. Any questions? Cool.